Alright, so we are going to work together the example calculation on slide 90 of our chapter 10 notes. I'm doing this with y'all online because there are quite a few homework problems that involve this type of calculation, and I think it's going to be helpful for me to show you exactly how to set it up. So our problem says that Charles has increased his activity by doing more exercise, and after a session of using weights, he has a sore arm, so he uses an ice bag filled with 125 grams of ice at 0 degrees C, and they want to know how much heat in kilojoules is absorbed to melt 125 grams of ice and raise the temperature of the water in the ice pack to its body temperature of 37 degrees Celsius. So in this problem, we are basically going to be doing two calculations to figure out how much heat it takes to melt our ice, transition it from the solid state to the liquid state, and then we're going to figure out how much heat it takes to raise the temperature of our water once it's in the liquid phase from 0 to 37 degrees C. So we're going to have two steps, and there'll be a calculation for each to figure out energy required, and then at the end we're going to add up our total heat together. So for our first step, it's basically how much heat do we need to transition ice at 0 degrees Celsius to water at 0 degrees Celsius. Now, our ice is starting at 0 degrees C, and we know that's the temperature that ice melts at. So for this calculation, if you consult back to, hold on, let me find it on here, slide 86, it shows you a bunch of different types of calculations you can do. So we're going to be using the melting calculation because we're going from solid ice to liquid water. So that means we're going to need a mass and the heat of fusion for water. And this is a given value that I believe we talk about, let me look, on slide 78. Basically, heat of fusion of water is how much energy is needed to transition water from solid to liquid or liquid to solid. Okay, so we're going to use this equation. Melting is equal to mass in grams times our heat of fusion, and that's in units of joules per gram. So in our problem, it states, if we go back to slide 90, that we have 125 grams of ice. So melting equals 125 grams multiplied by my heat of fusion for water, which is 334 joules per gram. So if we perform that calculation, multiply those two things together, our grams cancel, and we're left in units of joules. And if I plug that into my calculator, I get 41,750 joules. Now, if you're following along on your PowerPoint, it says that we want heat in kilojoules. So in order to change joules to kilojoules, we can divide by 1,000. And I'm going to go ahead and round as well. And I get that that equals 41.8 kilojoules of heat. So that's just my first step. How much heat is basically needed to perform this phase change between going from ice at 0 degrees Celsius to water at 0 degrees Celsius. Now in the problem, the second part is that basically we're raising the temperature of our water from 0 degrees Celsius up to body temperature of 37 degrees Celsius. So my second step, we're looking for how much heat is added to raise water temp from 0 to 37 degrees Celsius. Now this requires a second type of equation, and if we go back to slide 86, we're going to be looking at the liquid equation, which we have used this type of equation in a previous chapter. I don't remember which one, but it's basically mass times change in temperature times specific heat equals energy amount. So for our liquid temperature change, we're going to be using this equation where we have mass in grams times change in temperature in degrees Celsius times specific heat in units of joules per gram degrees Celsius. We have our mass. We can figure out our change in temperature, and specific heat of water is another given value. I believe it is 4.184 joules per gram degrees Celsius. And if you look at the slides after slide 90, it does show you the values that you're going to need. So before we start plugging stuff into this equation, I'm going to figure out what my change in temperature is, which you can probably do in your head, but I'm going to show you how to do this calculating. So change in temperature, it's final minus initial temperature, so it's 37 degrees minus 0 degrees Celsius, which probably could have figured that out already, is 37 degrees Celsius. So now I can plug everything I need into my equation. So mass, still 125 grams, change in temperature, 37 degrees Celsius, and specific heat of water is 4.184 joules per gram degrees Celsius. So if we multiply all this together, grams cancel, Celsius cancel, and I'm left in units of joules, which I get 19,351 joules. Now remember, our problem asks for kilojoules, so I'm going to divide that by 1,000 and get roughly 19.4 kilojoules. Now that's just basically assuming that I rounded my significant digits to 3, since that's the minimum amount in the problem. So now we have our energy that's required to transition from ice to water, 0 degrees Celsius, and we have our energy that it takes to raise the temperature of our water from 0 to 37 degrees Celsius. Last step is to figure out total heat involved, and that is simply basically adding these two steps together. So 41.8 kilojoules plus 19.4 kilojoules gives me total heat of 61.2 kilojoules that it takes to raise the temperature of ice from 0 to change it to a liquid at 37 degrees C. So that's our final answer. Thanks for listening, and hopefully that will help you complete your homework.